So formally, welcome to session 2 of the Steminar series Intro to Python. I'm your corny host, Professor Ryan Ammons. I'm not too formal, by the way. You can refer to me as Ryan or Professor Ammons or instructor, or as long as it's not some expletive, I pretty much answer to whatever. I'll take that off. So if you're just joining us and you did not get an email or go to the site last week, you'll need to catch up. I'm not going to spend too much time on it, considering we only have 40 minutes left. But essentially, if you have not already, you'll need to go to this site, which this is all on profammons.com / intro to Python series with dashes. Let me just paste that into the chat in case anyone doesn't want to have to type that out and needs it. So that's the page where everything will be, as I noted earlier. So you'll need to go there and create an account that doesn't show that here. What we're going to do, since most of you, I think I see pretty much most of the names are people that were here last week, or hopefully you watched the video or looked at the slides from last time that I posted. You'll need to choose to create a new REPL. So let me show you doing that. So let's new tab. Let's see, get rid of the bookmark bars. Duplicate work. Okay, REPL, and you'll be logged into your account. You can log in using your Google identity. If you have a GitHub identity, you can do that, as well as I think Facebook. The creator, by the way, of REPL at the site was a former Facebook engineer, and there's a whole interesting story behind it. And if you're interested in that, let me know. So we want to click New REPL, and you're going to choose your language, just like in the slide shows, Python, not Python 2.7, not any of this other stuff. I'm going to talk a little bit about Pygame because it's very fun. And you can make nice interactive graphical games with it without a whole lot of coding, especially fun for the kids. But hey, you know, we all have, I'm a kid at heart. I like to think anyway. So, you know, playing around with this stuff is pretty fun. But we're going to use Python, just regular Python. This is actually Python version 3. It doesn't say it, but it's the latest version. That's why it's just Python. And you can, as the slide notes, you can keep the funny Silicon Valley-esque name, which is just 3 words, random words put together. This time, proper lively Quack. Yeah, I'm gonna change that. You don't have to, right? To, let's see. So this will be whatever you want to name it. It would be something like Steminar Intro Python Session 2. And then you want to hit Create REPL, and then wait a few moments, and you should have an environment for programming readily set up. You don't have to install anything, like I said last week. This is all in the browser. It should be a piece of cake, especially compared to downloading and installing tools. Is everybody to this point? Is everybody good so far? I guess I'll ask the inverse. So, is anyone not good? Is anyone having trouble at this point getting to here? So I'm going to wait a few seconds, make sure we don't have anyone left behind. Don't want to leave anybody behind. All right, I'll assume from the lack of response that we're good to go. Okay, so I'm going to go back to the slides now. We're going to talk a little bit about our topic today. So, first a review. So if you'll recall, last time we talked about the most basic things, which are using some variables and printing output to the terminal, as well as getting input from the terminal from the user. So let's go ahead and do that. I'm just going to do the hello world again, and remember to click run in order to run. And it will cause the script to run in the right panel, which is the terminal. And we see the output, right? It just says hello world. That's not very Very interesting, but it is, at least if you get that, you know you're good to go, you're working. All right, and as far as input goes, typically, you know, you want to assign the input to some variable. Input on its own is not so great. So again, this is a little review from last time, a couple of minutes. If I do this, which by the way, if you just copy and paste, it's not going to always work because, you know, Office, PowerPoint, etc. Changes the actual character. This is a good little lesson in how characters work and how computers interpret codes. And that is, a quote, a double quote is not always a double quote. Double quotes are not the same all across the character spectrum. The double quotes that it tries to put in, and I've tried to fix that, you'll see here, so it is copyable, but sometimes it'll just revert back to its fancy quote, which is actually a different character. And you saw that character when I copied it over, it was invalid syntax because the Python language does not accept anything except the basic standard double quote or single quote. So be careful with that when you're copying and pasting and not having something work. Okay, so I'm going to run this, and as you'll recall, this is the prompt that is shown to the user. You don't have to have one, we could leave it out, but then the user is kind of left wondering with a blinking cursor or not blinking cursor, depending on your terminal, what they should input or not, or what they should do at all. In fact, I'll run it like that, and you'll see it doesn't end because the end would follow with a little terminal mark, the orange little triangle to the right, pointing to the right, the greater than sign. Right now it's waiting on input, right? Which is what this is. So I can type some input, press enter, and now it ends, right? See, that's you know the program has ended. Also, it's indicated by the run button. It will remain in the stop mode, so you could stop, terminate the program manually until it's actually terminated naturally, which is at this point terminated. So we want to put that prompt back in and say, hey, type your name. So I'm going to type my name, Ryan, hit enter, and you notice nothing really happens. It's not very useful. The point being, going back to the slide, we're going to need to save that somewhere to be able to use it. Right now, we're not really saving it. Technically, it is saved in memory, but we don't have a handle for it, right? It's like a suitcase without a handle. You can't pick it up. You can't grab it. You can't take it with you. You can't access it. It's something you might be able to find if you looked really hard, but you need some special tools, just like trying to pick up a suitcase or something like that without a handle. So the handle is going to be the variable name, and we're gonna assign it to, say, let's use something straightforward like name, which is in the slide. Sorry if you can hear that creaking outside. I have no idea what's going on out there. Apologies if that is coming through. Name equals, a single equal sign stands for assign. So assign or set whatever is on the right equal to, or assign its value to, what is on the left. And here that is name, the variable. So if I run it again, hello world, type your name, Ryan, enter, well, still not really doing anything, except this time I do have this suitcase, so to speak, with a handle on it. And the handle is this symbol called NAME, name. It could just as well be X or I. You can pretty much make up whatever you want as long as it doesn't turn blue, which means it's a reserved special word, and you can't start it with a number. It has to be started with a letter. It is possible to start with underscores, but let's keep it simple for now, and we'll just call it name. I'll do it just to show you some variation. Name 1. Okay, so it is there, but we're not using it. Right, so the program terminates and it's gone. So let's print it back out, and let's say your name is, and I noted last time people preferred this method of concatenating or gluing strings together rather than the formatting version, which is a %s. You can just put commas and separate values. That is perfectly acceptable in more complex programs, and if you go further in the language, you will definitely need to learn how to make use of and understand the usage of these replacement values. But it's okay. For now, we're just going to keep it simple. I don't want to overcomplicate it. So your name is, and then comma, and then the next thing we want to print out is name1. You'll notice the IDE, which is repl in our case, it picks up the fact that there is a special symbol called name1, and it says where it is. It's in this special function called main, which we haven't defined. We're not really going to talk about that, so don't worry about that for now. Just ignore it. But it will actually do what's called code completion. So if you were to say, oh, it's already selected using the arrow keys, then you could just press enter and it will finish it for you. That's a nice feature of an IDE and a productivity tool of the massively lazy software developer, of which I am still one. Even though I teach, that is my profession now. I still actually work in the private sector and do this. I manage developers as well as do development. So I can attest to the fact that we're a pretty lazy bunch. Anyway, so run this and you get hello world, type your name, and there you go. Now we actually have some useful output, right? We're using what value was put in by the user. It was put into this variable, which is referenced using this symbol name, name1. And then we printed back out, or output back out to the terminal, the string, which is just a string of characters. Your name is, and followed by that is the whatever the value that is inside of name1. And there it is. Your name is Ryan. And just as well, I could put in Bjork or something like that. My name is definitely not, but that's how that works. So that's just a short review of of the last session and input, output, and basic variables. Duck typing, quack quack, haha. If it looks like a duck and it quacks like a duck, it's a duck. It's sort of a semi-formal way of referring to how Python handles variables and data types. Data types are very important, even though you don't have to deal with them a lot in Python, because the computer treats different types of data differently. Now, at the end of the day, all of the data is simply zeros and ones. It's all binary. However, how you tell Python or the CPU to interpret or use the data, it could be video data, image data, text, executable code for a program, because code is just data. It's just interpreted as something that can be used to tell the computer what to do. That is what a data type is for. It is to tell the computer how to treat a piece of data. So here we have an empty variable called x. It's not set to anything. If we just do that, it doesn't really have a data type. Technically it does, but we're going to assume for now it doesn't, just simplify things. If we wanted to create this one, Python is cool, whether you think this is true or not. We're going to set this equal to this special value true. Capital T R U E. Now this is not a string. This is actually a Boolean value. Now Boolean values are going to be very important in what we're doing today. True or false. A Boolean can only be true or false. It can actually be a couple other things, but we're going to, again, stick to the simplistic version of it being true, or if you think this is false, then it would be false. And I will put this now in. Let's take this, comment that out. By the way, that's how you comment things. You can do it quickly like I just did. Highlight lines and press Control front slash, which is the slash that is on the question mark key. If you press that, it will automatically toggle the comment on a line. You can also manually do it. It's hashtag. Hashtag on a line. Anything that follows the hashtag is ignored by Python. So what I'm going to do now is Python is cool. I'm going to create this variable, and I'm going to say equals true. And then I'm going to do something that you don't have to know how to do, but I'm going to say type. I'm going to print out the type of Python is cool. So the data type. I'm asking the language to tell me what is the data type, what is the type of data that is in Python is cool, the symbol, the variable, and then print it out to the console. So let's run it. and we get bool, class bool. Don't worry about the class and all this other character. Just focus on bool. Boolean. That's short for Boolean. It's named after a famous guy. His last name is Boole. So this is Boolean logic. He pioneered the mathematical branch Boolean logic, which is essentially true, false logic, and how you combine them with ands and ors to get useful results. And essentially, it is the foundation of what is called classical computing now. Now that we have quantum computing, regular computing like what we're doing is actually referred to as classical computing. And it is all based on ones and zeros and true and false. There are no between states as there are in quantum computing. There are only zeros and ones. And the zero usually meaning false, the one typically meaning true or on. So we get that data type, right? And we didn't have to say this is a bool. In Java or C++ or C or many other languages, you would need to say bool in front of it and to say to the language specifically, I want to use a Boolean value here. And it would not allow you to not do this. You would be required to say it's Boolean. But you don't have to do that with Python. It does take a performance hit, so Python is not as fast as a lot of other languages in terms of execution and overhead, largely because it takes care of a lot of things for you without you having to deal with them. But that means the computer has to do more work that you're not doing for it, which means it's slower. So this is where duck typing comes from. Like it looks like a Boolean and it quacks like a Boolean. So it's considered a Boolean, right? It just figured out that's a Boolean because I set it equal to true. Now, if I say Python is cool and I put it in quotes, true, does anybody have an idea what this is going to tell me? What kind of data type this might be? Maybe some of you, maybe more advanced folks, if you've seen this before. Yeah, string, exactly. So if I run it, it's going to say, yep, there it is, str, which is just short for string. That's the actual symbol for string in Python. So it's a string. And if I set Python is equal to 1, anybody got an idea what that would be? Int, integer, correct. And if I said 1.0, what do you think? Floating point. So double is a type of floating point. Single, double. You'll find those that you may have heard of those if you've done any C++ or Java or a ton of other languages. But floating point is essentially a way of storing decimals. Computers aren't really great at doing decimal numbers. It's always an approximation. And the reason it's called floating point is because the point floats. It's essentially scientific notation. So you get something like 1.0 times 10 to the 0, right? This would be 1.0. And if it were, say, 11.1, then that would be 10 to the first, right? That would be 11.1 in scientific notation. And essentially floating point is a means to represent decimal values using scientific notation format. And that's why they call it floating point, because the point floats, right? Just like in scientific notation, it floats left or right depending on the exponent that is applied to the base. Here it's always 10, right? Or in our system, just because we happen to be evolved with 10 digits, and we chose that as our counting system. Although not all cultures have base 10. So there is an interesting thing there, and if you want to know more about that, send me a text or email later, and we can have a fun discussion about number-based systems. But we'll move on now. So now that we have some ideas about data types, we want to move on to today's the more interesting thing. So a program is not particularly useful if it can't make decisions. Right? We want to be able to make decisions based on input, based on state, based on whatever the user's putting in or the environment is showing, which those are synonymous with input and state. So in this case, I've got a little diagram here that I made, a little game, which sort of hints at where we're going. So start in a flow chart, right? That's where the the program starts, and you have an end, which is where the program ends. So that should be pretty self-explanatory. And then you have steps in between. A logical flow, right? So we show introduction. This is going to print out the introduction to, say, hey, welcome to our game. And then it's going to say, hey, you need to choose a cave. Say cave 1 or cave 2. And then there's a dragon in that cave. And it's going to say, if the dragon is friendly, which we're going to represent as dragon_is_friendly as a variable. And it's going to be true or false. This is going to be a Boolean variable. Dragon is friendly. If it's true, that's going to equate with, yes, obviously dragon is friendly. That's true. And it would go this direction, down this path, which means the player wins because the player gets to live, right? So otherwise, it would be false, right? That's the only other option we have at this point for a Boolean. I haven't talked about the others, and we won't in this seminar. Dragon is friendly. So if that is false, which we're going to assume that is equivalent to is hungry and not so friendly, it would go down this path, right? And that is the else path, right? If true, else, otherwise, right? If it's true, do this, whatever is inside of here. And it would, in this case, it just prints out dragon friendly true. And this more complicated sort of case, which is just a diagram, it's not actual code. It would say player wins, which would be this case. Otherwise, the only otherwise being it would have to be false. It prints out dragon not friendly and player loses, right? So does that make sense? I'm trying to make this, this may be really way underneath a lot of your intellectual levels. I apologize. I'm just trying to make it as accessible as possible. Excellent. So, but if anybody has any problem, let me know. Don't want to lose anybody here. Because, we're not born knowing this stuff. This is not intuitive. Computers aren't intuitive. Oh, where do I take the Boolean value? Where do I measure it? So it's measured automatically. So this gets to, I guess, the next slide. I'll just go to the next slide. This is the general. So you have a little character here looking, is it true or is it false, right? It's looking. And this character would represent, whether or not the value, and then it would be true or false, and it would go that direction. So essentially you have a condition, right? And it measures that condition. Now, I made it really simple because I used a Boolean directly. So it's true or false already inside this variable. If dragon is friendly is true, and you know what, we can just do this. I can just take it over here and then paste it. And I'm going to have to make some changes, comment that out. And then make sure to get your white spacing correct, by the way. That's the technical term for empty space, white spacing. So it has to be, Python is really finicky about this. So essentially, if you have an if statement here, colon, you press enter, it will automatically put you on one tab over, which is where you need to be. You can't be one space over to the left or to the right. It won't work properly. So make sure you keep your tabs like that. Print dragon friendly true and else. And then I need to make sure this is also lined up. And by the way, what I just did there, you can either hit backspace or pro tip, shift tab. Tab goes to the right, shift tab goes to the left. So just, pro tips on programming. How do you get a random value? Try math random. We'll talk about random values at some point. That's actually one of the exercises. I don't think it's next week. Maybe it's next week. I don't remember. But today we're going to keep it simple. I don't want to introduce any libraries or anything for random. But if you want to know before then, shoot me an email, rammons@nvcc.edu, and I'll be happy to give you the process of how to do that before we do it in the normal course of the seminar. Okay, so I need to have a variable here, right? Right now there's nothing called dragon is friendly, and so if you hover over it, I get this like in Word, if you have a misspelling or some kind of syntax, I guess syntax is generally green, but a spelling error, you'd have this similar thing. And here we have a very big problem, and that is we don't have something called dragon is friendly. So we need a dragon is friendly variable. So we're going to make one, dragon is friendly, and we're going to set it equal to false. So we're going to just assume the dragon is not friendly. So dragon is friendly, false. This will, anybody got an idea what's going to print out here if I ran this? Yes. Oh, and you import the library. Not friendly. Absolutely, right? It's not friendly. Dragon, not friendly. Because if this is true, do this, else do that. This is not true, so do that. Now change it to true. Run. Dragon is friendly, true. Right? It only executes one path. That's why you see in the flowchart, there's only one way to go. You can't have both of these happen. You can only have one happen. Okay, and then it ends. Now this is probably not particularly interesting. This is just a really basic intro to how Boolean values work. And essentially, this is always a Boolean. If always looks for a condition which can be true or false. That's just how classical computing works in general. However, you may want something a little more complicated, more useful. In this case, I've given an example here. Quantity 10. I made a variable called quantity. I set it equal to 10. And then I said x equals, this is just whatever. I just used a random, the normal x or I or j variable to hold the input from the user, which I convert to an integer because it's a string when the person inputs it. It's actually, so whatever you type in is actually a string, but we need a number because you can't say greater than, you can actually use a string with less than or greater than, but it's about alphabetical order in that case. But that's not what we want. We want to compare a numeric value. And to do that, we need to convert the string input, which we get from this, into an integer, which is just wrapping the int function around that. And that is a syntax error that should have had 2. I don't know if I deleted that just now or I had that incorrect. Don't worry, the slides should be correct when I post them. So what we're going to do is take this over. And I'm going to just get rid of this. I'll put it in comments and push it down somewhere so that I can share it with you as code later. All right, so you'll notice here it picked up, when I copied and pasted it, some white space, a tab. And you notice that is not correct. Unexpected indent. So an indentation, a tab that should not be there. It can only be inside of a clause. For instance, this is an if clause. Anything inside of this if is one tab over. So it visually aligns with what is quote unquote inside of this execution path. And it's also how the language works. Now, I'm not the biggest fan of white space, using white space for this. Most other languages use something like curly braces or other types of notation to denote where a block of code starts and where it ends. Python does not do that. So I need to push this back over to match the same indentation level of the same block of code it is in. So I do that, and then I need to fix my quotes again. So I'll do that. And then let's see, how many do we want? Let's go ahead and finish the rest of the program, pull it over. So we can take this and copy, paste it over. And for the most part, it looks okay, but we need to pull this back over. So the if and the else should be at the same indentation, which is none. And then inside the if, we put the print here, and then we want to pull this over. So this print underneath the else is also in the right the right indentation level. All right, so let's run this and see what happens. Let's run. How many do you want? I want, let's see, 10. And if I hit enter, we don't have enough because 10 is not less than 10. 10 is equal to 10. And since this evaluates to the Boolean false, this does not get run. It goes to else, and else executes whenever this doesn't happen. Whenever this is not true, else gets executed. It's probably more helpful as well to replace this 10 here with this value quantity, or this symbol quantity, because that's really what we want. We want a program that's reusable, and we don't have to go through the code and change quantity to 10 everywhere that it is referenced. So what we were really doing is asking, did we have the correct quantity? Did the person want less than what we have? And that might not actually be correct, right? In that case, you may have noticed, well, if we have 10, why can't we do that? Maybe the business rule here was at least keep one as a floor sample or a floor model, right? So we don't want to sell 100% of our inventory. We want to keep one on standby, at least to have something that the customer can come in and look at. Obviously not during these times, right? But to look at in order even to know whether they would want to pre-order it or order it for us to order into inventory. However, say for instance, we wanted to be able to sell all of our inventory. Well, then we could change this to, instead of X less than quantity, we can change it to less than or equal to quantity. Now that will be true for 10. If X is 10, that would be true, or less than 10 would also be true. Now it's not equals less than 10. That would not be correct. It's always, and there's a very specific reason for this, and that's because there's an operator. There's a special operator that is used that uses this notation. So the equal sign is always the second of the two when you combine greater than or less than and equals. Should be annoyed at what again? Which I'm not quite. I don't quite follow the question, Owen. Oh, so this is a function. Print is a function. And you call a function, you have to open the parentheses, pass in the arguments. You'll note from last time, if you were here or watched the video, we argue at the function. We yell at the function and we give it something to do, right? And this is the argument. And then after the argument or arguments, if there are multiple, you have to close the function call, which is in parentheses. And you should notice if you put your cursor on the ending parentheses or closing parenthesis, the one on the left is highlighted as well. Oh, you're talking about this inside of here. No, even in Java, that would be acceptable. The issue with Java would be something like if I wanted a backspace, right? Then you need to, and I talked about this last week about escape characters. So if you want a new line, that would be a new line. So that's similar. No worries. No worries. It's a good question. So yeah, and then of course you don't want to do this like in Java and a lot of other languages. They also have line termination characters, which means that you could put things on multiple lines and not worry about it as long as you ended it with a semicolon or whatever the language uses. However, Python is a whitespace language, which means it just uses enter character, new line, etc. to know when to start and stop things. So we don't need a line terminator other than just your normal enter. Okay, so we want to change this to less than or equal to quantity. It also matches, by the way, in your normal parlance in English to say the less than or greater than or equal to. You don't usually say equal to or less than. It's usually the inequality is first in that clause. So that also makes it sense as to why it's that way. But it has more to do with syntax than that at the language level. All right, so let's try that. Let's do it. And let's say I want all of them. I want it all. So we say 10 and hit enter. Oh, we can do that because now we're allowing it to also be equal to. So does everybody follow this logic of how this gets evaluated? So this condition always has to be something that can evaluate true or false. And that's pretty much the basic of how if and how the programs you run and will make decisions and follow different execution paths and be useful, right? Because let's face it, if you can't make a decision about how to take different input, it's not useful. Because if it keeps telling you the same thing, no matter what you give it, it's definitely not going to be something you would want to use in a business or even for a game or any other use. except as maybe a practical joke, I guess, if you wanted. But that's not particularly, that doesn't have a whole lot of utility. All right, so that's sort of the basics of if-else. Now we're going to go to if, elif, else. Now, this is going to look really weird. It kind of looks weird even if you haven't done a language before. But if you worked with any other language, elif is going to look kind of funny. Elif is the else if. In other words, what if we have more than two conditions that we want to test? In this case, our example that I've made up, the dragon is friendly. Well, we win if the dragon is friendly. But what if the dragon isn't friendly, but it's asleep? Well, if we had else, we would have a hard time doing this, right? You technically could put another if-else inside of here, and that's actually what happens in C++ and other languages. But typically you'll find an else if, which in this case is an elif in Python. So that means you can test multiple conditions, and then if you've exhausted all of those conditions, in other words, this is false, the dragon is not friendly, and the dragon is also not asleep, then you get to the else, right? And you can put as many elifs as you want. You can put elif, 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 elif. You can have 100 of them. Exactly. It's a second or third or fourth or fifth or sixth choice. Now, the thing is if any of them are true, if I had 5 here and say the second one is true, all of them were false, and then the second elif is true, it will execute what's in that elif and then jump out of the entire block of if, elif, else. It will not execute any of the other elifs. It will not even check them if they're true or false. Yes, you can have an array of arrays. And technically, what you use in Python for an array is a list. And I think that is the last, and probably hopefully not the last session. If you guys like these and are more, if I get a lot of positive feedback, we'll continue this series. But the last scheduled series is for collections. Collections is the general term for data types that hold multiple items. An array being one of those. And in Python, the most basic one is a list. So you typically use a list rather than an array. It's more or less an array, but it's called a list in Python. No, it's a good question. So note here as well, I put in the else that it prints 2 statements. And we know that it'll print 2 because they're both at the same indentation level. I have not gone back to the left to be flush with the left in line with the if, elif, else, right? So that's where the indentation really comes in handy. Up to this point, it hasn't been as clear maybe as to why this is important. But if I kept putting statements at this indentation level, they would all only execute if this else were executed, which means that every one of the if and elifs were false. So let's run this. Let's go ahead and do this. In fact, I don't need to do this. I need to just pull this over and then change the messages. Don't worry, I'm going to share this code with you. Just try to follow along as best as possible. I know we have 2 minutes left. I'm doing my best here. Try to get done and get to the fun game part that a good friend of mine made. He's an auditor and knows a lot about accounting, and it's something, today's would have been tax day normally, but odd circumstances, sort of once in a lifetime, delay pay and file taxes. I know some of you are too young to know what that is, or what the consequences of that is, but normally it would be tax day. So the project I'm going to have you work on, and we're going to start right after this, and then we'll sort of end on it. And I'll go a little long if you want to stay on, but I want to try to wrap it up for those that have to leave at 3. Okay, so we don't have enough. We can do that. So this actually needs to be replaced by dragon friendly when, right? So I do that, dragon friendly when, dragon, and I need to change this, right? This is no longer what I want to use. I need to change this to dragon, and I don't have to have the parentheses, by the way. Dragon is friendly, and we need that variable back. So we're going to say dragon is friendly, and we're going to say that's false. We'll start off, and then dragon is hungry equals true. So we're going to put elif dragon is, and see, I don't have to type. I can be lazy. I can choose here with my arrow keys or with the mouse, preferably arrow keys. It's easier. Get used to it if you want to do some programming for the long term. Is hungry. So dragon is hungry. So this is going to look at whether or not these are true or false, and definitely it's going to execute. Which one do you think it's going to execute? Dragon, hungry. I actually messed this up. Sorry. This actually should have a not in front of it. If not, if dragon is not hungry, then you lose. It should be lose for each. We can take the not out and keep it simple. Dragon is friendly. This is what happens when I make up my own examples and I have to do it late at night. Sorry about that. If dragon is friendly, you win, right? But if dragon is hungry, then you lose. But what we actually want to know is dragon is not hungry. I'm sorry. I'm looking at the two different things. I just completely got myself messed up because I was looking at the flowchart and not the code that I actually wrote. The code I actually wrote is correct because it's talking about being asleep. Apologies on that. The hungry was just an alternative to friendly, which is not really captured in the code. So let me fix that really quickly. Is sleepy, is asleep. So is asleep true. Now this makes a lot more sense. I apologize. I just confused myself. See, programming's hard, even if you've been doing it for 20 plus years. Believe it or not, it's also a little more difficult when you're talking to a lot of people and trying to like look at the chat and pay attention to multiple things. I know I'm just making excuses now. I shouldn't have made that mistake. But you see, don't worry. If you make a mistake, you can feel okay because I've made a couple of mistakes here, right? So dragon is asleep. So we'll say dragon asleep. That's what we're going to print out to the user. Hey, you win. And we'll do a little exclamation point, make the person feel good. And then we'll say not friendly, not asleep, lose. And notice again, these are at the same indentation level. And I'm going to put at the end, print thanks for playing, right? Now this will print no matter what because it's not inside of the else. It's not inside of any of these. It's back to the left. Now if I put a indentation, it will only print thanks for playing if this executes, the else, right? But if I move it over to the left, it will happen no matter what. So let's try it. Let's run this. Dragon asleep, win, right? Which that's true because dragon is friendly was false. So this doesn't happen. Else if, or elif, dragon is asleep is true or false. Is it true? It's true. So do this. Well, it does that, and then it skips all the way down outside of this block, right? It doesn't print this. Now, if I change this to false, so both of them are false, and remember, we could keep using elif. We could have other conditions. Dragon is away at the moment, or dragon is fishing, or whatever you want to come up with. Yeah, I'm gonna. In fact, I'll just copy this over to the chat. I had somebody ask, so if you want to go ahead and paste this in right now, you can just copy that over, and it should mostly work. You might have to fix some of the indentation, but hopefully it'll be more or less accurate. Okay, so there we go. Thanks for playing. Now, if I move this over one, I get this. Because thanks for playing is inside of else. And I put both to false. So it didn't execute this, it didn't execute this, it did execute this. But what if I change that back, or just the first one to true? Now it's going to say dragon friendly. Yes, dragon friendly win. Will it print thanks for playing? Exactly. Dragon friendly win. But it does not print thanks for playing. See how the indentation is very important. So if I move it back, then we're good. Then it'll print it no matter what. Okay, so I know I'm out of time, so what I'm going to do is, first of all, this is the solution for last week. I think I sent the email out for it. If I didn't, I'm going to put that in the chat. Yeah, we're going to do that. Or I'm going to give you the starter for it. So this is the text adventure game starter that was written by, like I said, a good friend of mine, Chris Martin, who couldn't join us today because he's at work downtown DC. There's the so yeah, you probably want to make different REPLs, so you can make as many as you want. Create a new REPL every time you have a new little project, even if it's only a few lines, because you don't mix everything together and end up with errors because you have some old things in there that don't work or interfering with your new code. So this is going to be our project for the week based on what we've talked about today. And yeah, that was it. And this was just a funny one here. Like, does it move? No. Yes. This is sort of a flow chart of an if else. Should it? No, no problem. If it should, WD-40. Yes, it should move. And it shouldn't move, then duct tape. This is like the engineer's really simple handbook. So in this case, this would do the if, elif, else, and I'll post these slides, don't worry, on the same site, the same page that has everything from the first session. And I'll also post this, the link to this starter. What it does is, I've already given you sort of the setup. It prints out the title of the game. You know, I give credit to the person who made it. And then it says, the wicked dragon has terrorized the kingdom for far too long. A hero steps forth to challenge the dreaded beast. And then you get to choose your hero. And instead of using just normal prompts, I need to put some more complex information here. And so I say, choose your hero. 1 is for knight, 2 is for wizard, 3 is for IRS auditor. You can see where this is going, and it was supposed to be tax day related, but funny. Which do you choose, 1, 2, or 3? And then the user should put in 1, 2, or 3. This is the input part, right? And then it converts to an integer, because that's what we need. You could not convert it to an integer and just say this, right? You could take the string 1 or string 2. I just find it easier to use integers. That's up to you, though. You can play around with that. And then it says, if hero equals 1, by the way, you need 2 equal signs for equality. 2 equal. Yes, the recording will be posted. So if you need to go now, everything is being recorded and the rest of it will be there if you need to just look at the end. So I appreciate your time. If you do need to go, please feel free to drop off and I will send out an email again. But it's on the same page. I'll just make sure that you guys have the link to it. So we'll talk more, like I said, offline, Owen, about the lists. But you can definitely get the link. There is a method for length, for size. So if hero equals 1, that is equality. This is assignment. So this is setting something, setting a value to something. But if you want to ask if 2 things are equal or equivalent, you must use 2 equal signs. This would not be valid, right? In Java and C++, this is a common error because you can put a single equal sign and it won't yell at you. But what that does is it just sets hero equal to 1. It doesn't ask if hero is equal to 1. And that always returns true, which is not what you want. You want equals 1. Is it equal to, right? 1. And in that case, everything that is indented 1, 1 tab over underneath that will happen. So here, in this case, just like a text adventure game should, it gives you a scenario. Brave knight sallies forth. He strides boldly into the dragon's cave to do battle. What weapon does he use? And then we have a new variable we call weapon, just like we did for hero. And we're going to say weapon equals int input, just like same formula, just repeat, rinse and repeat here. That's a lot of programming actually, is rinse and repeat. Just try to follow the pattern. Int input, the magic sword, that would be 1, or the sacred lance, 2. And then we have another if else, right? This is inside of this first if. So it will never happen if elif hero is 2, a wizard, right? And I've left a lot of this for you to finish right? You have all the text and everything. So the weapon is magic sword. It prints out magic sword. You'd actually want to print this out, right, and not try again because we haven't done loops yet. So I'll take that out. And then else, right? That would be you chose something else. So even if the user put in 3 or 4 or 10, it would actually say either else. But what we really want is sacred lance. Right, so this sort of takes care of anything other than 1, right? You could do else, elif, 2, and then do else, and then say you didn't choose validly, you lose. You could always do something like that. I'm just making it as simple as possible. So let's run it really quickly, and this will be the end of the public session. So here we go. We got our nice text adventure, Dragon Slayer, story by Christopher V. Martin. The wicked raider of dragon has terrorized his kingdom for far too long. A hero steps forth to challenge the dreaded beast. Choose your hero. 1 knight, 2 wizard, 3 IRS auditor. So essentially, what we're going to do here is... So we're going to choose the IRS auditor first, just to be funny. And it says the IRS always wins. Which is a joke, right? I mean, they sort of do, but that's supposed to be a joke. And you're supposed to fill this out. I just put this in here as a placeholder so the program would run. Because if you don't put anything underneath an else or any other of these clauses, it will actually throw an error. So I needed to put something here just to make it function so that you could at least run it to see what it looked like before you started going and changing it. So I'm going to run it one more time. I'm going to choose knight, which is the one I've done at least the next step for. So if I do that, well, there we go. Hero is equal to 1, so it's running this block of code. So it says what it's supposed to say, and then it says magic sword or sacred lance. It asks the user, and it's waiting on input. What weapon? So we're going to say sacred lance 2, and it says sacred lance. And then last thing I'll run is I'll choose that again, knight, except this time I'm going to put in 1, 2, 13. And normally that would make no sense, right? And if you want to make an elif else here to do something like, hey, that's not an option. What are you talking about? You can do that. But in this case, it's an else, actually. So anything other than 1 will get you the sacred lance. And this is how you can maybe see also how bugs happen in games you may have played or programs that you use. Someone shortcutted or used a shortcut in order to save a few lines of code, and they end up with bad user input allowing things to happen that should not. Right? In this case, it's not really consequential, but it can be in certain applications. So are there any questions before I end the public session? Was that useful? Is anybody having technical difficulties getting anything to work? So I got a couple thank yous. You're very welcome. I'm very happy to do this. I'm hoping that there's enough interest that we can continue and do some more things with, say, Pygame, and even maybe do a data series so we can talk about how to do data manipulation and simple data mining, because that's a big part of the field. And maybe even there is a cybersecurity seminar or seminar. I don't know how much they go into Python with it. Probably some to some extent, but I'd be happy to do something like that as well going into the summer. All right, so I don't see any more questions. Glad you got something out of it. Again, I'll post this recording and all the materials related to it to the same site. I'll send out one more email. I try not to flood everybody's email inboxes. I know you're probably getting a lot these days. So I'll just send one email out that will be another link and reminding you where you can find all of the materials. Otherwise, I wish you all a nice rest of the day. Stay safe, stay reasonably sane, and I hope to see you guys all next time. And if you have any questions in the meantime, please don't hesitate to contact me via text, via email, through my website, however you like. All right, everybody. Thank you so much for joining.